Hey everyone. Chapter 9. Chapter 9, we need to know how to factor. So, we're going to spend a few days on making sure we remember how to factor. Lots of different kinds of factoring. This sheet is both notes and homework. So, I'm going to do one from each chunk and then, or each type of factoring, and then you guys are going to have the rest for homework. First kind of factoring is greatest common factor, also known as GCF. What are we going to do? We're going to factor out the greatest common factor from each term. We choose the largest number that goes into all of the numbers, and you will choose the smallest exponent that's common on one of the values. So let's look at let's do number 2 because it seems most interesting. The first thing I'm going to do is I'm going to look at the numbers. I got a 12, a 16, and an 8. What number goes into all of those? That's the largest. 4 goes into all of those. And then we're going to look at the exponent parts with the variables. I've got a y squared, and a y cubed. I'm going to have to pick the smallest of those, so that's going to be a y to the first. And then what's left over? 4 times what is 12? 3. Y times what is y cubed? Y to the second. Plus, look at the middle term here. 4 times what is 16? 4. Y times what is y squared? Y. Plus 4 times what is 8? 2. Y times what is y? 1. So the 2 times 1 gives us just 2 at the end. And then if I look at the trinomial here, there is nothing that's common with all of those terms. So I am done. Looks like that. Okay, so in the other three, I need you to find the greatest common factor, pull it out. Next up, trinomial factoring. So this is kind of like the regular factoring that you do when you have a quadratic. Just a refresher here, polynomial, let's say we have x squared plus 16x plus 48. I need two numbers that will add or subtract to the middle value, the 16, and I need two numbers that will multiply to that last number, 48. So we have lots of different number pairs that'll multiply to 48. We've got 1 and 48. We've got 2 and 24. We've got 3 and 16. We've got 4 and 12. We've got 6 and 8. So which of those pairs, when I add or subtract them, do I get to 16? The 4 and the 12. So then when I factor it, it'll be x plus 4 and x plus 12. If you go ahead and FOIL this, distribute, you're going to get back to your x squared plus 16x plus 48. If you don't, then something went wrong. If you do, yay me, pat yourself on the back, you did a good job. All right, let's try one more. Let's try the third one, x squared minus 2x minus 24. So I need two numbers that add or subtract to -2 and multiply to -24. Factor pairs for 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. So which of those, when I combine them, I can get to a 2 or a -2? The 4 and the 6. So I'll have an x and a 4. I'll have an x and a 6. I needed a -2. So I'll need a -6 plus a +4. Double check that the 4 times the -6 really does give us that -24 that we needed. Okay, so you've got 4 more here. Nice and simple. Leading coefficient is a 1. You should be able to handle all of those. Next up is difference of perfect squares. You know you're going to be checking for a difference of perfect squares when there's only two terms versus the other ones. The one before this was a trinomial, 3 terms. In the end, we'll have two binomials. One will be a sum and one will be a difference. So our formula, if we have a squared minus b squared, will be an a plus b and an a minus b. If you want to switch that around and have an a minus b times an a plus b, totally fine. All right, some perfect squares. Let's list the perfect squares. We got 1, we got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. There's the first 12. You should know the first 20 by heart, okay? So now what? So we're going to look at these, and is it going to be a difference of perfect squares? Remember, it has to be a difference, meaning there has to be subtraction between the two, no addition allowed. So let's try number 2. If we look at number 2, I've got a 4x squared. Is that a perfect square? Yes, the 4 is a perfect square. Yes, the x squared is. Then I look at the 81. Is that a perfect square? It is. So I'm going to end up with two binomials. Think of it in terms of slots. The square root of 4 is 2. The square root of x squared is x. The square root of 81 is 9. So I'll need a 2x and a 9 here as well. One is addition, one is subtraction. Those signs being opposite result in your middle terms, negative 18x plus an 18x, for those to drop out. They cancel, so then you're really just left with the first terms, or x squared, and the last terms, minus 81. So there's your double check that you do indeed get what you started with. All right, so you got a couple more of those to do. Split middle term, these are, in my mind, the least fun of the kind. So it's just a regular trinomial. The difference is we no longer have a 1x squared, we have some other number there. So let's say we have 2x squared minus 7x minus 15. I need two numbers that add to negative 7, and I need two numbers that multiply to negative 30. So what are my errors for 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6. So what combination of those can get me to a negative 7, the 3 and the 10? So I will need a 3 and a negative 10. So I'm going to take this middle term, the negative 7x, and I'm going to split it up into negative 10x plus 3x. If I combine that back together, I get the negative 7x. Then what? Then I'm going to take the first two terms, sorry, that's negative 10x, and I'm going to take the second two terms and I'm going to group them. So kind of like factor by grouping. Then what? I'm going to take out the GCF of each pair. So if I look at the 2x squared minus 10x, I can take a 2 out and I can take an x out. So what am I left with? I'm left with x minus 5. And then in the second pair, I can take a 3 out and I'm left with x minus 5. Now, if you've done this correctly, you're going to get a match. So then what? So then one of my factors is the x minus 5, and then what's left over? The leftover part is the 2x plus 3. Again, if you want to check this, FOIL it, clean it up, and you should go right back to the beginning. I'm not a huge fan of split middle term. I usually prefer guess and check, but I'll do the split middle term until you guys get a little better or you remember it well. All right, so which one of these do you want to do? Which one? I didn't hear you. Tell me again. Which one do you think it's going to be? It will be 1, 2, 3, or 4. And the winner is 4. All right, so the first thing we're going to do is we're going to multiply the 4 times the negative 15, and we get negative 60. And then our add part is the negative 17. So what are some factor pairs for the negative 60? I've got 1 and 60. I've got 2 and 30. I've got 3 and 20. I've got 4 and 15. I've got 5 and 12. And I've got 6 and 10. That's a lot. Okay, so I need a negative 17 when I add or subtract these. So ironically, I have two that could work. These can both get me to a 17. I need a negative 17. So, and I need a negative 60. The negative 60 tells me I need one positive and one negative because that was multiplication. So to get a negative 17, I would need those both to be negative on the 5 and the 12, so that one's not going to work. So I'm going to need the 3 and the 20. I'm going to need a 3 and a negative 20. So I'm going to take the 4x squared, the negative 17x, I'm going to split up. I like to do the negative first. Usually just makes it a little bit easier. And then plus the 3x. So again, these middle terms go back to the negative 17x. We're kind of splitting it apart. And then we've got the x minus 15. Then what? Then I'm going to group. I'm going to group the first two and the last two. So I'm going to look at this first chunk, the first set, and what's common there. I can take a 4 out, I can take an x. What am I left with? I'm left with an x minus 5. Then I'm going to look at the second grouping. What's common there? I can take a 3 out, and I'm left with an x minus 5. Yay, an x minus 5 and an x minus 5. So then I take the x minus 5 out. What's left over? The leftover part is the 4x plus 3. All right, so anybody guess 4? Who thought I was going to do 4? Anybody? Anybody? All right, so that's that for split middle term. Next up is grouping, and that's going to be where we will start on Friday. So for Thursday's work, you only have to do through split middle term. All right, and then we'll start grouping on Friday for Friday's half day of stuff. Okay, all right, thanks guys, bye.